Hello dear students, welcome to Konar classes. In this session, we are going to discuss homogeneous differential equations. Before we proceed, let us first understand what is a homogeneous function. Okay? So I am writing the definition, and after that we will look into it with few examples. A function f x comma y is said to be a homogeneous function of degree n if of lambda x comma lambda y is equal to lambda to the power n f x y. What is lambda? Where lambda is a non-zero constant, and what is n? And that n belongs to capital N, the set of natural numbers. So a function, I repeat dear students, that a function f x comma y is said to be a homogeneous function of degree n if lambda x comma lambda y is equal to lambda to the power n into fxy, where lambda is a non-zero constant and n belongs to capital N, the set of natural numbers. Let us take an example. Suppose we get a function called f1 x comma y is equal to y square plus 2xy. Let us see whether this function is a homogeneous function or not. For that, what we need to do, dear students? For that, we need to write that what is the value of f1 lambda x lambda y. That should be equal to what? Lambda y whole square. Instead of y, we should write lambda y plus 2 into, instead of x, we will write lambda x, and instead of y, we will write lambda y. Correct? So from here what we get, dear students? So lambda square into y square plus lambda square into 2xy, because from here one lambda become lambda square. Now from these two, what we can write? So this is equal to lambda square into y square plus 2xy. So what is y square plus 2xy? It's nothing but f1 x comma y. So that is equal to lambda square into f1 x comma y. So what we see, dear students, that we are able to express that f1 lambda x comma lambda y is equal to lambda square into f1 x comma y. So what we can say? We can say this function, this given function, is a homogeneous function of degree 2 because it is lambda power 2. Now, that is another way also we can find whether a function is a homogeneous function or not. This is one way of defining. Another way of defining is something like this. A function if x comma y is said to be a homogeneous function if we can express that f x comma y is equal to either x to the power n into a function g y by x, or we can write that function f x comma y as y to the power n into h x by y. Okay. So this is one definition. Another definition is that if we can express f(x, y) as x to the power n into a function of y by x, or the function f(x, y) is equal to y to the power n into a function of x by y. Remember, when we write x here, the denominator becomes x here in this function, and when we write y here, the denominator becomes y. Let us take the same example. f(1) x, y is equal to y square plus 2xy, and let's see how we are going to achieve it. Okay, so let me take a different color. Yeah, so this is one definition. Another way how we can write it down, so we are going to show that how we can see this is a homogeneous function of degree 2 by means of this definition. Okay. Okay, so how to write it down here, dear students? So our given function is f(1) x, y. Okay, so this is equal to what? This is equal to y square plus 2xy. Now what we are going to do, we are going to take x square common. So if we take x square common, then what we will end up with here? It is y by x whole square plus 2 into y by x. Correct? So now if you look into this particular expression, okay, if you look into this particular expression, this contains y by x. That means what? It is a function of y by x. So that is equal to what we can write? This is equal to x square into g y by x. This definition, x square into g y by x, where g y by x is this function. That means what? We can say this function is a homogeneous function of degree 2. Now other way also you can express it. How? Let me show you. The same function, okay, another way we can express. Okay, so let me do it here only. Yeah. Okay, so what we can write, dear students, is that the same function y square plus 2xy, we take y square common, then this y square become 1 plus 2 into x by y. Correct or not? So now if you look into this particular function 1 plus 2 into x by y, that is a function of x by y. So what we can write? This is equal to y square into h x by y. Correct? What I was telling, dear students. So if you look into this particular one, that 1 plus 2 into x by y is nothing but this h x by y is a function of x by y. So if you look into this, that we are able to express f(1) x, y something like this, y to the power n into h x by y, here y to the power 2 into h x by y. So from this way also we can say it is a homogeneous function of degree 2. Okay, so you can apply any of this definition, either this definition or this definition, okay, or this definition or this definition. As long as the solution of a homogeneous differential equation is concerned, in most of the cases we will be using this particular method. In most of the cases. In very few cases we will see this method as well. Okay, we will see one by one. So dear students, what we can say, that a function f(x, y) is said to be a homogeneous function of degree n in x and y if that function can be expressed as x to the power n into g y by x, where n is any natural number, that is belongs to capital N. Fine. So let us see couple of more functions, okay, and also see one function which is not a homogeneous function. Okay, so I can write the function here. Let me write one here. Let all the three definitions be available, and then we are writing one by one function. The next function what I am going to write, dear students, is that the function f(2) x comma y. Okay, and suppose the function is 2x minus 3y, and we are going to see that whether it is a homogeneous function or not, and if it is a homogeneous function of degree what, that also you are going to see. First we are going to apply this definition. That means what you are going to do, so f2 into lambda x comma lambda y, where lambda is a non-zero constant. So that becomes what, dear students, 2 into lambda x minus 3 into lambda y. Correct. So now from these two we can take lambda common. If we take lambda common, then we get 2x minus 3y. And what is 2x minus 3y? That is f2xy. So that is equal to lambda means lambda power 1 into f2x comma y. Why I write power lambda power 1? Just to show that it is a homogeneous function of degree 1. Correct? Because it is falling into this definition, lambda power n, where n is equal to 1 in this particular case. Now the same function I can write something like this. This function, what I am writing in the blue color, is that I am going to take x power 1 common. Then what we will end up with 2 minus 3 into y by x. Now if you look into this particular expression, that is 2 into 3 y by x, this is nothing but a function of y by x. So this falls into this category, x to the power n into g y by x. Here also x to the power 1 into a function of y by x. So from this definition also we can say this is a homogeneous function of degree 1. Correct? So far we have seen this definition, and this definition. In this definition also we can show it. How? Let me show you. So the same function, so let me do it here. I just do not want to erase anything, so from here I am going to write. So what we can write, f2, what we can write is that f2x comma y, that is equal to, from here we take y common. Y common means y to the power 1 common. So what we are going to get, 2 into x by y minus 3. Okay. Now if you look into this particular expression, 2 into x by y minus 3, it is an expression on x by y. So the same function f2x comma y, we are able to write y to the power 1 into 2 x by y minus 3, which is of this type, y to the power n into h x by y, where h x by y is something like this. So from there also we can say it is a homogeneous function of degree 1. So dear students, what we get something like this. The same function f2 lambda x lambda y, we are able to express that lambda to the power 1 into f2x comma y. We are able to write x to the power 1 into a function of y by x. We are able to write y to the power 1 into a function of x by y. So whatever the branch of definition you follow, we will end up with the same thing. It is a homogeneous function of degree 1. Correct? Let's take another example. Okay? And the function is that, dear students, I am going to write it here. As I always say, you also write along with me. Okay? Then your learning will be absolutely complete. You don't need to spend any other time. Whatever the time you are spending in watching this video, that same time your learning will be complete. Okay. So the next function what I am going to write is that f3x comma y is equal to cos y by x. Okay. So now if we write this thing, that f3x comma y is equal to cos y by x, let us follow this definition. Okay. f3 lambda x comma lambda y is equal to cos lambda x divided by lambda y. That is equal to what, dear students? Cos of x by y, because lambda is not equal to 0. If you recall that I always say lambda is a non-zero constant. Lambda is a non-zero constant. So that is equal to, we can write that lambda to the power 0, cos, x by y. Okay. So what we can say is that, we can say that lambda to the power 0 into cos x by y. So we can say this is a homogeneous function of degree 0. And one statement I can make, dear students, when we say that n set belongs to the set of natural numbers, and also we can add the this union the element 0 also, means the value n could be 0, 1, 2, 3 like this, means 0 or any natural numbers. Okay. So f3 lambda x comma lambda y is equal to lambda to the power 0 into cos x by y. From there you can say it, from this definition we can say it is a homogeneous function of degree 0. Now let's see this definition. If we apply this definition, it is a pretty simple. This is equal to x to the power 0 into cos y by x. So from this definition also we can say that it is a, from this definition we can say it is a homogeneous function of degree 0. Okay. This branch of definition we should not apply it here. And most importantly, homogeneous differential equation is only applicable for those homogeneous function which is of degree 0. If it is not of degree 0, it is not a homogeneous differential equation and we are not going to find a solution for it. I repeat once more that when we are discussing about homogeneous differential equation, that concerned homogeneous function has to be a homogeneous function of degree 0. Okay, like this kind of function, not the previous two functions. Now before we proceed for the solution to homogeneous differential equation, let me show you one function which is not a homogeneous function. Okay, so what is that? That is the fourth function we are going to take. So let's take this function as f4 x comma y. Okay, f4 x comma y, and that is equal to, we can write sin x plus cos y. Okay. Now if you are going to apply this definition of homogeneous function, so that means what? f4 lambda x comma lambda y, that should be equal to sine of lambda x plus cos of lambda y. Correct? Now this we cannot express as lambda to the power n into sine of x plus cos of y. We are not able to. Okay, as we are not, where n is 0 or any natural numbers and lambda is a non-zero constant. Sin lambda x plus cos lambda y, we are not able to express as lambda to the power n into sin x plus cos y, where lambda is a non-zero constant and n is either 0 or any natural number. As we are not able to express, then we can say this function sin x plus cos y is not a homogeneous function. Okay, and the similar manner, if we apply, if we try to use this definition, here also you cannot see, we cannot express this as x to the power n into a function of y by x. We can't. Okay, so where n is 0 or any natural number, we can't. Similarly, we cannot express this as y to the power n into h x by y. Okay, so we cannot say that this is a homogeneous function. Okay, so now the most important part is that if a function is a homogeneous function of degree 0, how to solve this type of differential equation, that we are going to discuss. So now before we proceed for solving homogeneous differential equation, for the last time I am saying a function f x comma y is said to be a homogeneous function of degree n if f lambda x lambda y is equal to lambda to the power n into f x comma y, or f x y is equal to x to the power n into a function of y by x like g y by x, or f x y is equal to y to the power n into a function of x by y like h x by y, then we can say this function is a homogeneous function of degree n in x and y. And what is lambda? Lambda is a non-zero constant. And what is n? N can be 0 or any natural numbers. And we are going to solve homogeneous differential equation in which the concerned homogeneous function of degree 0. Now the question is that how to solve it, okay? So for that let us take a homogeneous function. Okay, so how to solve this one? So let us have a differential equation something like dy dx is equal to fx comma y, where that fx comma y is a homogeneous function of degree 0. That means what? That means you can express this fxy as x to the power n, sorry, not n here, homogeneous function of degree 0 means specific value of n is 0 into a function g y by x, correct? That means what? That means in simple terms we are able to express dy dx is equal to g y by x. Okay, this is the differential equation. Okay, after that what are the steps to be followed to solve homogeneous differential equation? The step 1 is what? That we should write y is equal to v into x. This is the substitution we are making. The moment we write y equal to v into x, let us differentiate both sides with respect to x. Then what we are going to get? This implies dy dx is equal to v, means it is a product rule, v into ddx of x, that is 1, plus x into dv dx, differentiation of v with respect to x. Now this value of dy dx, that is v plus x into dv dx, we are going to apply here. Means if we apply here the value of dy dx as v plus x into dv dx, what we are going to get in the right hand side, dear students? It is nothing but g of what is y by x is v, y equal to vx, that means y by x equal to v. So this is gv. Now from here what we are going to do? From here we are proceeding in this place is that x, so this implies x into dv dx, x into dv dx is equal to gv minus v, gv minus v. This implies dv divided by gv minus v is equal to dx by x, correct? Simple. Now after that what we are going to do? We are going to integrate both the sides. Okay, this is a function of gv minus v is a function of v, we can integrate, and integration dx by x, and once we solve this integration, we get the general solution or primitive. Okay, we will see one example. Okay, without solving a particular example we cannot have our understanding very clear. Now before I proceed for an example, I would like to say you something, and that thing is that if you get the function, so let me write it here, if we get the function expressed as if the differential equation is something like this, that dx dy is equal to fx comma y. Notice the difference. Here it is dy dx, but here it is writing dx dy. but the function is fxy, means it is a function of x and y, and also it is a homogeneous function of degree 0. That means what? That means in simple terms we can say dx dy is equal to, you can write a function of h x by y. Okay? If this is the case, then your substitution should be x equal to v into y. Remember, when it is dy dx substitution is y equal to vx. If the given question is dx dy, then the substitution should be x equal to vy. After the same thing, here we will differentiate both sides with respect to y. That means dx dy, product rule of differentiation with respect to y, that means v into d dy of y, that is 1, plus y into d dy of v, that means dv dy. Correct? And same thing, here we will apply the value of dy dx, dx dy value we will apply here from here. This implies we will get v plus y into dv dy is equal to h, x by y is equal to v. Correct? So in the similar manner we get what? That y into dv dy is equal to hv minus v. Correct? So from here we get that dv divided by hv minus v is equal to dy by y. Correct? And after that integration both the sides. So mind that difference. Last time I am saying, if the question is dy dx and a homogeneous function of degree 0, right hand side substitution should be y equal to vx. If the given differential equation given as dx dy is equal to a homogeneous function of degree 0, then your substitution should be x equal to vy. Okay, mind this difference. Now let's proceed to a question. Okay. So the question what I am going to write, let me write it from my notebook, okay, and we will solve together. Okay, so here is the question. Okay, so that the differential equation, I am noticing that differential equation as dE. What is the differential equation? X minus y into dy dx is equal to x plus 2y is homogeneous and solve it. Is homogeneous and solve it. So first we need to so that this differential equation is a homogeneous differential equation. So how to do this thing? So from this given equation, that is x minus y into dy dx is equal to x plus 2y. That means what we can write, dear students? Dy dx is equal to x plus 2y divided by x minus y. Now first we need to show that this function which is there in the right hand side is a homogeneous function of degree 0. Okay? Because if the function is not a homogeneous function of degree 0, the concerned differential equation is not a homogeneous differential equation. I repeat, to have this differential equation qualify to be a homogeneous differential equation, this particular function has to be a homogeneous function of degree 0. So how to do this thing? So this implies dy dx is equal to, as it is dy dx, we are going to express as x to the power something. So what we can take? X to the power 0 in this case, by the way, means we will take x common and denominator of the x common, it will get cancelled. So in the numerator we get x common, means x to the power 1 common, we get 1 plus 2 into y by x, correct? And in the denominator we take x power 1 common, we get 1 minus y by x. So what we get, dear students? So from here we get dy dx is equal to x to the power 1 and x to the power 1 get cancelled. So that means we can write x to the power 0, and if you see in the numerator is 1 plus 2 into y by x, and denominator is 1 minus y by x. So whatever I have written inside that curly bracket, if you see this one is a function in y by x, so it is a homogeneous function of degree 0. Hence the concerned differential equation is a homogeneous differential equation. Now how to solve it? For solution, what you need to do is that we are going to make the substitution, okay, is that y equal to vx, okay, and that let make the substitution here. Let y equal to vx. This implies what? Dy dx is equal to v plus x dv dx, product rule in the right hand side, v into ddx of x, that is 1, plus x into ddx of v, that is dv dx, and that value we are going to apply here. So from here we are proceeding. So then what we are going to get? Dy dx is equal to v plus x dv dx is equal to 1 plus 2v, 1 plus 2 into v. Why? Because y by x equal to v, as y equal to vx, so v is equal to y by x. That means instead of y by x we can write v. 1 plus 2v divided by 1 minus v, correct? So from here what we can write, dear students? So from here we can write x into dv dx is equal to 1 plus 2v divided by 1 minus v, minus v here. So from here what you can write, dear students? So x into dv dx is equal to, in the denominator it is 1 minus v, in the numerator it is 1 plus 2v minus v into 1 minus v, correct? So from here what we get, dear students? So this implies x into dv dx, that is equal to 1 plus 2v minus v plus v square. Let me write in elaborately, 1 plus 2v minus v plus v square divided by 1 minus v. Okay, so that implies what, dear students? So that implies, we can write x into dv dx is equal to v square plus v plus 1 divided by 1 minus v. Okay, so from here let's come back to this particular one, because this integration will need some space. Okay, so let me write it here. So from this one, so from this one we are coming to this portion. Okay, what is this? That 1 minus v, that implies what? 1 minus v divided by v square plus v plus 1 into dv is equal to dx by x, correct? Clear or not? Okay, so from here what we can write is that v minus 1 divided by v square plus v plus 1 into dv is equal to minus dx by x. After that what? We need to integrate this one, integrate this one. Okay. Now mostly we need to concentrate on integration of this left hand side. Right hand side though is minus log of mod x, you know. So how to do this thing? Okay, for that you need to follow my integration class, the steps, detailed step by step. To know the detailed step by step process, you need to follow my integration class. It is available in the online test platform. Okay, but let me do it quickly here. So this implies what, dear students? So first you need to make the differentiation. What will be the differentiation of the denominator? 2v plus 1. So in the numerator you need to first make 2v plus 1. So now in the numerator we see v. So to make it 2v, we need to multiply it by 1 by 2. So that here we get 2v minus 2 divided by v square plus v plus 1 into dv is equal to minus integration dx by x. Right hand side integration we will do at the end. Now the differentiation of the denominator is 2v plus 1. So we need to first make 2v plus 1. But what is there in the numerator? 2v minus 2. So first we make 2v plus 1 and then minus 3. Correct? So from here what we get, dear students? So 1 by 2. So we will break it into two different integration. One is that 2v plus 1 divided by v square plus v plus 1, this integration dv, minus 3 integration dv by v square plus v plus 1, correct, is equal to minus integration dx by x, correct. You can give brackets also. What is the integration of 2v plus 1 by v square plus v plus 1? As the differentiation of the denominator is in the numerator, so we can directly say that this entire integration is nothing but log of mod v square plus v plus 1. So from here what we can write, dear students, that 1 by 2 into log of mod v square plus v plus 1, correct, minus 3 into, this is very important. Okay, so what to do this one? So the denominator has to be, make it as a perfect square of v and with the adjustment with the constant term. So that means what, dear students? So we can write integration dv divided by, we can write v square plus 2 into v into 1 by 2, because in the denominator coefficient of v is 1. Now to make it a perfect square, we make 2 into v into 1 by 2. After that we will make 1 by 2 whole square, so that this first three terms will become v plus 1 by 2 whole square. Now as 1 by 2 has been, 1 by 2 whole square has been added extra, so we should subtract. So 1 was already there, so I write 1 and minus 1 by 2 whole square. Okay, that is equal to minus integration of dx by x is equal to log of mod x. Now as we have performed the integration, so let us add c1, and c1 is the constant of integration, correct. So now what we are going to do, dear students? So from here we can write 1 by 2 into log, what is v? If you recall, we applied y equal to vx. If you recall, I have removed that portion. That means v is equal to y by x. We need to apply back the value of v is equal to y by x. Why? Because v was our assumption. In our result it has to be in y and x. So that is why v has to be y by x. So we are writing it here, v is equal to y by x. So that implies what? Y by x complete whole square plus y by x plus 1, okay, minus 3 integration dv, denominator is v plus 1 by 2 whole square, v plus 1 by 2 whole square plus 1 minus 1 by 2 whole square is 1 by 4, 1 minus 1 by 4, that is 3 by 4, and 3 by 4 means what? Root 3 by 2 complete whole square. If you have any question that why I have written in this way, you need to refer to my integration class, but this gives in the form of integration dx by x square plus s square, this form. And right hand side whatever is there, minus log of mod x plus c1. Okay, one thing, as we have this entire 1 by 2 was multiplied with the entire thing, so here instead of 3 it should be minus 3 by 2, and here also the same thing. Correct? So what we are writing it here. So now let us from this particular part, okay, let us go back to this particular one. Okay, from here let's continue. So what it will be, this implies 1 by 2 into log mod y square by x square plus y by x plus 1, this mod is there, and this minus log x I take in the right hand side, take it in the left hand side, so it becomes plus log of mod x is equal to 3 by 2. So in the left hand side what is there, minus 3 by 2, in this integration I took it in the right hand side, so it becomes plus 3 by 2 integration dv divided by v plus 1 by 2 whole square plus root 3 by 2 whole square, okay, plus that integrating constant c1. Correct? Now as we are performing this one, let me take some space from here. So this implies what, dear students? This log of mod x I can write it at 1 by 2 into log of mod x square. Why? Because we know there is a formula of logarithm is that n log x is equal to log of x to the power n. If you need to know how, you need to follow my logarithmic class. So now as we are able to do this thing, so we can take half common. If we take half common, then what we are going to get in the first expression, log of y square plus xy plus x square divided by x square plus log of mod x square, correct, is equal to 3 by 2. What is this integration? Integration dx by x square plus a square is equal to 1 by a into tan inverse x by a. So it is 1 by a means 1 by root 3 by 2, that means 2 by root 3, correct, into tan inverse of x by a. X is what? V plus 1 by 2 divided by a is what? Root 3 by 2 plus c1, correct. So now from here what we can write, dear students, in the left hand side, if you see that 1 by 2 into log one quantity plus log another quantity. So we can make it a product because we know log m plus log n is equal to log of m into n, correct or not? So here also that we get that 1 by 2 into log of y square plus xy plus x square by x square plus log of x square inside mod. So we can make the product. So what we can get, 1 by 2 into log of mod x square plus xy plus y square divided by x square into x square, correct. is equal to 3 by root 3 got cancelled, that become root 3, and 2 got cancelled, and tan inverse 2v plus 1 by root 3, 2 into v plus 1 divided by root 3 plus c1. Correct? I hope it is clear. So that will become what, dear students? That we get this x square and x square get cancelled because x square cannot be equal to 0. So from here what we get, 1 by 2 into log of mod x square plus xy plus y square is equal to root 3 into tan inverse. What is the value of v? Y by x. 2 into y by x plus 1 divided by root 3 plus c1. Now let's multiply both sides by 2. Then what we are going to get? So this implies log of mod x square plus xy plus y square is equal to 2 into root 3 into tan inverse of 2y plus x divided by root 3 into x is plus 2 into c1. Correct? So finally what we can write is that this implies log of mod x square plus xy plus y square minus 2 into root 3 into tan inverse of x plus 2y divided by root 3 into x. Okay, that is equal to 2c1. We consider another integrating constant as c. So c is equal to 2c1. So you can write where c is equal to 2c1, and this is the solution to the given differential equation. Okay, with this note, let me conclude the class here. In the next session, we are going to solve few more questions on homogeneous differential equations. Thank you very much. Bye.